In this lesson, we are going to discuss the fast way to calculate the normal using recalculate normal function from Unity, and to discuss the difference between the hard surface and smooth surface and their relation with the normal vector. We'll start by using recalculate normal function at Unity. Let's go for C# code. In our C# code, let's make comments in our normal calculations. Also, let's comment the assignment of normals. Now quickly let's go for Unity and press play. If we hold our light now and we check the calculation, first of all you can see the direction of the light now. It is in this direction, but still our screen is lighting, which obviously there is a mistake because we already comment the normal calculation. So now again we back to the old mode, which is the wrong calculation for the light and the shadow. So let's go back to correct it at our C# code. Now, after UVs, let's using mesh dot recalculate, and we'll get the normals function, and that's it. So let's save it. Let's see Unity again. What's happening? Now you can see the light direction opposite, so it is in shadow stage. Now, if we make rotate, you can see once the light hitting the surface, it will become green again. When the light go back, it will become shadow. So now we get the behavior same previously, same as we calculated. Now the question is, then why we calculate it? First of all, if we can Unity recalculate the normals. Actually, for normal situation, which means you want to build the normal mesh, and you want just to recalculate normal, we'll use the function, the built-in function from Unity. So we'll use recalculate normals. However, if you want to apply some special effects, then you mostly will need to think about using or assign the normal to our vertices manually, because maybe you need some effect. Once the light is reflected, it shouldn't be show as the expect, should be some different criteria. Then you will play with the normal direction. Maybe you are using some styles themes in your game, and you want the shadow in the face of the characters to show some kind of reflection for group of vertices, which maybe if you use in the normal way, it will not show in the same way you want it. So when you assign normal manual way, you can play with the direction of the light and the shadow. Just keep it in that. But for normal calculation or for normal situation, you will use recalculate normal, and that's it. Hard surfaces with smooth surfaces, or hard shading with smooth shading. What's that meaning? Let's first go to Blender to understand this point. In Blender, we have here two shapes, one cube and one the Susan monkey from Blender. Now, let's start by the cube. Now, here in the cube basically is polygon shape which have clear, sharp edges. So if we look to it, we can see this is the shadow coming in one surface. So if there is a lighting coming affecting our 3D mesh, each surface have unique light or shadow. So this surface fully shadow, or this surface have full light, or this is maybe little lighting. Now the point is here, all the normals in this surface are equal and same and distribute and have the same value and the direction. So all will get the same reflection of the light. This direction is the same. This is, in this case, this is what we call it hard shading. So why we call it hard shading? Because when you see edges between two surfaces, you will find a clear difference between both surfaces if there is a light effect. So like this, you can clearly differentiate between the shadow surface and the light surface. However, yeah, this one not always good. So let's say in mechanical parts, in hard surfaces parts, this is very good shading system because you need to expose the edge very well. For example, you are modeling a car, you are modeling cabinet, TV, mobile, any thing you have the hard surfaces, then this is very good for shading. Now let's move for Suzanne head. In Suzanne head or the monkey, this is organic shape. In organic shape, you can see the hard surface is not good because all the lines of the polygon it is visible, so it's make it like mechanical part, so it's look like more robotic more than organic shape. Now to solve this issue, we have to use the soft shading. So let's see what is soft shading. If we take soft shading, you can see now it's smooth. If we go for tab, this is the number of vertices. You can see all vertices in the same location, but when we're using the mesh shading, it is flat, it will become again the edge visible. Again, we are using the same number of vertices, but we are adjusting the way how to calculate the shading or the lighting. Now if we make it smooth, you can see the surfaces become smooth. If we go back to the normal or object mode, you can see the surface clearly. However, if we go for the cube again and we apply the soft shade, you can see our cube become somehow something wrong in our cube, because the cube should have clear edge. Now you cannot see any clear edge. Why? Because we are applying here the soft shade. In the soft shade, it will take the average of the normal vector between the surfaces and use it for calculating the light and the shadow. So it will be when near the edges, you will get the normal which have the slope. It will be for the calculation. But when using hard surface, you will getting exactly the perpendicular normal over the surface. Again, there is it's not like there is right and wrong. This is both methods are available for shading. If you are using hard surface, or you want hard shade lines and hard visible line or hard light, so you will use the hard shading or for the hard surface, which means for calculation of the normal. Now if you have organic shape or soft shape, maybe plastic, rubbers, and or skin of the character, definitely you want to use the soft shading to make it smooth looking. Now how to achieve it, we'll go back now to the coding at Unity to see how Unity handle this case. In Unity, now we will create a new 2 game object, empty, and we will assign code for them. So we'll create empty one and create the second empty. Now the first one we'll call it hard service. And the second one, soft service. In the coding also, we'll create one code for hard service, one code for soft service. First we'll start the soft service. For soft service, first we'll go for build a quad and we'll copy our code there. Let's copy the mesh filter and the requirement. And in the class, let's copy all the code. The class name should be soft service. save. First we'll explain the smooth surface. In smooth surface, as if we for our quad shape previously, we were using 4 point to generate two triangle, and we say the common vertices B1, B3 will share the both normal from both directions, and we will use the average normal for both of them. So what we are going to do in our example, we will push B2 in Z axis, so it will, this triangle B1, B2, B3 will be perpendicular in B0, B1, B3, and we'll see the effect. And we expect from this effect to be smooth, because B1, B3 will share, will take the average normal. So in the corner there shouldn't be unique normal, it will be average. So the transition of the light from first triangle to second triangle will work in the average in the line between B1 and B3, so it will be smooth transition. And that's it. Now what we have to do, we need to move the second point in the vertices. So we have point 0, point 1, point 2. Point 2 we'll move it in Z direction instead of XY direction to make both triangle perpendicular to each other. So this will become now 5, and this is, let's keep it 0 to make perfect perpendicular. And let's save our code and let's go back to Unity. In Unity, the soft surface, let's add the code, soft surface code to it. You can see automatically we assign the mesh filter, mesh renderer. Let's give material for our code, so we'll not see the flat pink color. And let's test the code. Okay, we can see here the soft surface have now shape. Actually, let's adjust the light 1 minute. Direction of the light, let's make it, let's fix it always to be direct light in our shape. So this will become 0. Yeah, that's better. Now in soft the surface, let's move it a little bit so it will be. And hard surface, let's move it also so it will not be in the same position. Now let's press play again. Now you can see in the soft surface, even this is two triangles perpendicular to each other. You can see here when you're watching, this is perfect perpendicular to triangle. But because the normal now is moving a smooth way, it is now and here in this point it's sharing the normal from this triangle and share this normal from this angle. So it's taking the average of it. So it's look like we are twisting the paper. So if we think this is like a paper or plane, then this is we twist little, so it's taking a nice shape for how to do it. It's smoothly. Even it is a perfect triangle, you cannot feel it is have sharp edge. And this is what's happening in soft surface. Now to understand the difference with hard, let's go move to the hard surface now. In hard surface, or to make the shape hard surface, we will add two vertices, which they will be identical in the same position of B1, B3. We'll call it B4 and B5. Basically what we are going to do, we are going to separate both triangles. So we will have one triangle B0, B1, B3, and we have second triangle B5 or B2, B4, B5. Now the first triangle, since it is not sharing the points B1 and B3 with the other triangle, it will have one normal vector, and this will be all in the same direction, perpendicular in the same triangle. So B0, B1, B3 will have, we expect to get the same perpendicular vector, normal. Now the other triangle, which will be perpendicular in our first triangle, B2, B4, B5, so it will also the same way, since the vertices B5, B4 will not share the normal with B1, B3, so they will have their own normal. And the whole triangle we expect to have one normal direction, which is perpendicular to the triangle, and it will be one color, or let's say one shape. In that case, because we separate both triangle and we separate the normal, you can see in B1, B5, which is identical points, but they are not sharing the normal, so each one have different direction of normal, so it will get different effect. So maybe this will get light and this is dark, and you will see the uniqueness of the edge between it. So let's test the code now. Okay, we are opening the hard service code. Let's go again, build the quad and copy all the code. Let's paste it down inside the class. And let's take the required component. So we'll start by vertices. Let's go in the vertices. Let's add 2 new vectors. So let's copy the last 2. And let's paste it. Ctrl V. 1, 2, 3, and okay, we can do one thing. We can make enter here, so it will be easy for reading. Yeah, that's better. So in the point number 4, it will be B4. It will be equal to B3. So it will be the same exactly. So it will be 500. And the last point, which is B5, it will be matching with B1, so it will be 050. For UVs, we will add also 2 new vector 2 to cover this point. Always remember, UV's number of item will be matching with the number of item in the vertices area. So let's add the new 2 vector. Can press enter and push it also. And same what we done for the vertices, or for the UV number 0, 1, 2, 0, 1, 2, 3, 4. 4 it will be matched with 3, so it will be 1, 0. And 5 will be matched with 1, 0, 1, so it will be 0, 1, so this will be 0, 1. Again, we are making identical with the previous shape, just only we are adding 2 new vertices to separate the triangle. And for the indices, we will change the second triangle from 1, 2, 3. It will become now 2, 4, and 5. Let's save the code. And let's see what will happen in Unity. Okay, first let's assign the hard service code to the hard service item. So let's in script and let's select our hard service. Then we will drag and drop the hard service code in our item. And let's not forget to add the material. So let's add the material and we'll add it in its location. Let's press play and see what's happening. Okay, we can see the shape here. The corner we not move it, so let's go back for our code. This one point we say we have to adjust, we adjusted already we move it in the smooth code, smooth service, now soft service, but in the hard service we not, so let's make it 0 and we make this 5, so we are pushing the corner to the back to make it right angle triangle. Again, we are comparing apple to apple between both objects. Okay, let's go back for Unity and press play again. And you can see this very nice sharp edge here it's looking. If we push our camera also a little bit so we can see in the scene. Yeah. I think if we move it like this and we make it rotate a little bit. Yeah. Exactly. So you can see in the render here in the game mode, this is very sharp edge. This is for the hard surface. You can remember in hard surface you will see the sharp edge. Again, the normals here in one direction, the normal for this triangle in the other direction. There is no average normal between the common points because we already assigned different points in the same location. But in the soft objects, we have sharing the normal between both triangle for the same point. So it is make soft transition in the light. So you can see here the light different, light different. Okay, let's even we try to blend the light a little bit. So if this is our light and we are going to rotate it, see the effect. You can see here, this is dark surface, this is light surface, but in the soft mesh, it is soft transition between it. You cannot see any of these hard lines. And this is very important. As in the future lessons, once we start modeling the objects, you will see how much important this point, especially when we're dealing with the curve shape like ball, or we're dealing with the soft meshes like character. And you will see how this will be very helpful. While the hard shape, it will be a hard surface, it will be very helpful for mechanical parts or for solid parts. And this is for the normals. Thank you so much. At the end, if you like the video, press subscribe and turn on the bell, and don't forget to share your opinion below in the comments.